So our learning targets today are operations and composition of functions, and we have to be able to add, subtract, multiply, and divide two separate functions, combining them into one, and state domain restrictions, okay? And then composition of functions and domain restrictions. Composition of functions is when we put one inside the other. If you didn't find the worksheets, they're in the orange bin. Nolan, underneath here. Look for worksheet 11 and 12, because that's tomorrow's. All right. This is a warm-up question about, is it continuous? The two places that this could be discontinuous would be, anybody know where we should check? I don't have a cursor yet. Yes, it says if x is less than 2, we have this rule. That's a line. It's continuous, right? So right up till 2, where it's an open circle. But then it switches rule, and we have... Sorry. We have to decide if it jumps there or not. Then it stays at 7 from 2 until 6. And then it jumps to this rule at 6. And we have to decide if it does jump on the graph or not. Sorry, guys. So if I put a 2 in this first rule, I'd have 4 times 2 minus 5 would be 3. Is that right, guys? I think. So there'd be an open circle there. If I, where does this start and end? Yeah, it starts at the ordered pair 2, 7, right? It just stays at 7. And it ends at 2, 6. Just kidding. It ends where? Somebody fix me. Good job. So it does jump there, right? From 2, 3 to 2, 7. This one starts at 6. And if we put a 6 in, we'd have, what's half of 6 squared, guys? So it'd be 36. Half that would be 18 minus 11 would be 7. So this starts, this parabola picks up at 6, 7. Is that the same place this one left off? Okay, that means it's continuous there. Okay, there's no jump. So where it, this probably should have said, where is it discontinuous? And what x value makes it discontinuous? Yeah, at x equals 2 is where it's discontinuous. On the quiz, you had to actually graph these. Let's see if I can give you a rough estimate here. This is kind of a steep line to the left of 2, like this. Then this was a horizontal line. Then this would be a parabola that starts at this same spot. And let's see, it was down here and it's going up, so it would be doing this. So it would have been discontinuous here. All right, so that's a review, and that was a concept on the quiz. All right, today we're doing function operations. Says two functions can be added, subtracted, multiplied, or divided to form a new function. For the new function, the domain consists of the intersection of the domains of the two functions, excluding values that make a denominator equal to 0. In other words, for each new function, the domain consists of the values of x common to the domains of the original functions. It can further be restricted by anything that would make the denominator 0. Okay, quick overview though. Repeat after me. The domain is all real numbers. Unless there's an x in the denominator. Or or there's this radical. Anything inside there's there you go. Okay, anything inside the radical, it says set the term inside the radical should be greater than or equal to 0 and solve. Okay, anything with a fraction in the denominator, you set the bottom equal to 0 and you say it can't equal that number. So this is about notation, this slide. When they write it like this, f plus g of x, it means you just take f of x and add g of x. When they write f minus g of x, you take f of x minus g of x. All right, the product they write a couple different ways sometimes. With the solid dot, or sometimes they will just write fg, which means multiply, okay? This is not the same as putting g inside of f or the open circle, okay? I don't know if you remember these from last year, but this means put function g into f, and we're going to do that in a minute. But the solid circle means multiply. And then f over g just means you put f of g on top of, or f of x on top of g of x, and that's the one that can have extra domain restrictions. All right, so I think we can do some examples here. This is done for you, but it says f plus g, so it had x squared minus x minus 6 plus the function g, which was x plus 2. You combine like terms and get x squared minus 4. The domain of everything, nothing had a denominator with an x in it, and nothing had a square root, so it's just all real numbers. All right, this one says find f over g. So they put this function on top of this function. Now, as soon as you do that, there's a domain restriction. X cannot equal what? What would make the denominator 0, guys? -2. So everything but -2 works. So that's what they've written over here in painful interval notation. And if we factor the top, this actually will simplify. They factored it here, and it was x minus 3 and x plus 2 over x plus 2, so you can cancel the x plus 2. But the domain restriction stays because the original function, okay, it yielded a 0 in the denominator of the original function, so therefore you have to say it cannot equal 2, or -2, sorry, even though it simplified. All right, here we go. We're going to try these examples. Everybody awake? F minus g, so we're going to write down x squared minus 3, that's f, and we're supposed to subtract g, which is 1 over x. Anything we can combine or simplify there? If they made us get a common denominator and do something, but we're not going there. We're just going to say this is our answer. But there is a domain restriction. What's the domain restriction? Yep. X cannot equal 0. If we were writing interval notation, it would say everything up to but not including 0 is the domain. But I'm okay with just saying x cannot equal 0. All right, over here, f times g. So f is x squared minus 3, and we're supposed to multiply it by 1 over x. I'm actually going to write that out in front because that's how we usually distribute from the front. Okay, right away we know x cannot equal what? X is in the denominator, so it can't equal 0. All right. Now, if I distribute, what is 1 over x times x squared? Can I simplify that? Becomes x squared over x, which would reduce to what? X. Is anybody awake? This is x squared is just x times x, and it's over 1, so I get an xx over an x, which reduces, 1 cancels just down to an x. All right, back here I have 1 over x times 3 over 1, which would just be 3 over x. How could we have, if we had left it with a common denominator? I don't know which way Abruzzo's doing this, and I really don't. If we multiplied this onto the top here, we would have just wound up with x squared minus 3 over x. Then it would have had a common denominator. Is either one of those any nicer to look at? I don't really know. Does everybody see what I'm talking about? This multiplied onto the 1 on the top would have just left this. Over here, it's written as two separate fractions. So we've divided the x into each one. I'm good with either one. Either way, the domain is x cannot be 0. All right, so let's try these crazy ones. It says, find f plus g, f minus g, f times g, and f divided by g. State the domain for each new function. All right, so f plus g, what would I get, guys? Can I combine anything? So I'll just get x squared minus 1 plus 2 over x, whatever crazy order you want to write that. I'm not going to worry about it. Where x cannot be 0. Otherwise, all real numbers would work. Okay. F minus g. Anybody? Where x cannot equal. Okay. F times g. So we'd have x squared minus 1 times 2 over x. You want to leave it a fraction? If we distributed the 2 across the top, it'll be 2x squared minus 2 all over x. If we divided it separately, what's 2x squared over x going to be? 2x. But this is also over x, so you'd have minus 2 over x. I think I'd just soon leave it like this. Either way, x cannot be. Now, this did factor, right? X plus 1, x minus 1 before we distributed it here. Is that going to simplify anything, cancel anything if we distribute it or factor it? So there's a lot of ways I would accept that answer. Okay, f over g, we just write this f over, yikes, 2 over x. Not sure we want to write it like that. What if we wrote x squared minus 1 is being divided by 2 over x? What do you do when you divide fractions? Yay, multiply by the reciprocal. So we leave this one, x squared minus 1 over 1, and then we flip this one, becomes x over 2. If we distribute that, what will we have? X cubed minus x over 2. Now, any domain restrictions? Yes, because the original function said x could not be what? Let me go back and double check this, but everybody got what they want there. Just like how this one at the end didn't have, it just said x minus 3, but the domain is still could not include negative 2. The definition back here says, for the new function, the domain consists of the intersection of the domains of the two functions, excluding the values that make the denominator 0. Common to the domains of f and g. So the original function domains matter. Okay, just a second. I'm going the wrong way here. All right, so for this question, this original function domain was all real numbers, and this original function domain was all real numbers except 0. The intersection of those, in other words, where they overlap, is all real numbers except 0. So that's the new domain for these, unless we have an additional restriction that we add. So the original domain could not equal 0, so we have to keep that. All right, let's try this one more time. Add them. Okay, f plus g. We're just going to have a hot mess, I think. X squared plus 4x minus 7 minus the square root of x. I don't think anybody's going to simplify. But what's the domain restriction? Anybody remember when you have a square root? What can you not take the square root of over the real number system? 0. Actually, you can square root 0. You can't square root what? Negative numbers. So x has to be good job. Okay, guys, when there's a radical sign, set the terms inside the radical, and this is supposed to say greater than or equal to 0 to solve. So x has to be greater than or equal to 0, or if we were writing the domain, it would look like this. I saw some confused looks. Do you get that the square root of 0 is 0, guys? Good with that part? Okay. So we can include 0. All right, anybody want to do f minus g? Almost identical. Where the domain is 0. There you go. All right. F times g. I just want to cry a little. So we have this function, and we're supposed to multiply it by square root of x. If I distribute that through there, it doesn't turn into anything nice. I get x squared square roots of x plus 4x square roots of x minus 7 square roots of x. All of those have what domain restriction? They still have to be 0 or greater. I'm thinking I could have even just said this was okay. All right, and last we have f over g. If I put this function over this function, I'm not going to make us rationalize it. Let's just leave it. I'm okay with it. But what does it change about our domain restriction? Can it still be 0 or greater? No. Yeah, it's got to be greater than 0. It could, in theory, be a decimal. But x is no longer greater than or equal to 0. It's now just greater than 0 because it can't equal 0 in the denominator. So it would now be 0 to infinity like this. Okay, the good news is I don't think either one on the quiz are that messy. Is there a nicer one we can practice? No? Okay, we'll see if we come upon some in a minute. The next is composition of functions. This is where you put one inside the other. So given f and g, the composition of f and g, it can be written like this, okay? Which is also sometimes they put all this gobbledygook around it. And it originally, you probably learned it like this. Does that look familiar to anybody? And you start at the inside out, right? So you're going to put g into f. It's also written like this now. The domain includes all values of the domain of g for which it in the domain of f, and this gets kind of hairy. All right, so it says for a composition of functions, when you're putting g into f, the domain includes all x values in the domain of g that map values to the domain. Okay, so we had our original domain of g and the domain of f, and the new has to include everything that works for both. The composition, which reads f composition g or f of g, okay, the function g is applied first and then f. All right, so I don't know why I have this 2 down here, but this example said find f of g, which might put g into f. So this was g, and we put it in here and in here. So we had 3 times 4x plus 2 quantity squared plus 2 times 4x plus 2 minus 1. Okay, we had to FOIL this out. 4x plus 2 times 4x plus 2, which gave me 16x squared plus 8x plus another 8x, which is 16x, and 2 times 2 is 4. Then we had to distribute this 3, which was 48x squared plus 48x plus 12. I'm going to write that in here. And then we had the rest of this on the back here, which was plus an 8x plus a 4 minus a 1. So we wound up with 48x squared. 48 and 8 x's was 56x. 12 plus 4 is 16 minus 1 is 15. All right. It also wants us to find g of f of x, which we don't have room for on here. And then it says, I don't know why this is on here, but find f of g of 2. Guys, there's 2 ways you can do this. We just found f of g to be this mess right here in green, okay? So we can put a 2 in there. Somebody help me out. What's 48 times 2 squared, which would be 4, plus 56 times 2 plus 15? All right, 48 times 4. That 192? And this would be 112? Oh, it's a 15, yeah. Plus 192? 319 maybe? Did anybody type it? You got 319? Okay, thank you. Now, there's another way to do this that I like much better. If this were the only thing I asked you right here, guys, f of g of 2, any ideas? What could we put the 2 into first? The g. So let's put the 2 in here. 4 times 2 is, plus 2 is 10. Then we could put that answer into f. So put a 10 in here. 3 times 10 squared, which would be 100, plus 2 times 10 minus 1. What's 320 minus 1? 319? Was that much easier? And if they didn't ask us to find what f of g was, I don't know about you, but I certainly could have made an algebraic mistake finding this disaster in here, right? So be careful. All right. We were also supposed to find g of f. Did I put that on the next one? Is this the same problem? Okay, so yeah, this is the second half. Okay, it says find g of f. So to find g of f, we're going to put the f into the g. So this time, do you guys have this on your notes? The f goes into the g. This is way easier, right? So you have a 4 and a something plus 2. But now what goes in the spot of the x is this whole f function, 3x squared plus 2x minus 1. Okay, can you simplify that? Did anybody get that mess? Did I distribute something wrong? So I had 4 times 3x squared plus 2x minus 1, which became 12x squared plus 8x minus 4, and then there was a plus 2 back here. Okay, any domain restrictions on there at all? Any denominators or radicals? Nope. So it's all real numbers. All right, number 3. We're supposed to find f of g and g of f, and then f of g of 4. Could we do this before we did anything else? How did I just show you to do this one the easy way? Put the 4 in for g and then that answer into f. Okay, so if I put the 4 in here, g of 4 would be 16 minus 8 minus 4, which is 4. And then I'm supposed to put that answer into f, which would be 2 times 4 plus 1 is 9. Okay, so now let's find the function and see if it still works. The function f of g is putting which one into which? G into f. So we write out f, and we put all the g function in where there used to be an x. Okay, simplify that, somebody. 2x squared minus 4x minus 8 plus 1 would be minus 7. Is that what we were supposed to put the 4 into eventually here? Right there? So let's double check that it works. 2 times 4 squared minus 4 times 4 minus 7. This would be 32 minus 16 minus 7. 16 minus 7 is 9. Okay? So that's a way to check that we did the algebra right, as it worked both ways. All right, but that was to find this answer. That had nothing to do with f of g, other than f of g of 4. Okay, what do we got left? Any domain restrictions on that? Just all real numbers? Okay, now we have g of f. So this time we have to put all this in here and here. Not as fun. Something squared minus 2, something's minus 4. Okay, I have to put a 2x plus 1 here and a 2x plus 1 here. What happens when I do 2x plus 1 quantity squared? Anybody know? Yep. And another plus 2x, which would be 4x. 1 times 1. Back here I'm distributing, so I get what? Good job. And then I add a minus 4 on the back. Okay. So all that simplifies down to 4x squared, minus 5. Did anybody get that? 4x squared plus 4x plus 1 minus 4x minus 2 minus 4. Everybody agreeing? Where the domain is all real numbers. Somebody got a question? Do you have a question? Good. All right. Oh no. I don't want to do this one. All right. It says f of g, so we're going to put which one into which one? Mm-mm. Yeah, it goes backwards, so it's g into f. That's not really as bad as it seems. Because what happens? Well, when we square 1 over x, it just becomes 1 squared is 1, x squared is squared. And if we multiply the 3 only multiplies onto what? Yes, so we get 3 over x squared minus 4. Now, if I saw this version only, I would want to say the only thing x can't be is 0. Because I can put a negative number in there and square it, right? The original function, what's the only thing x can't be? 0 can be negative. We can put a negative in. Okay. So it's all real numbers except x cannot equal 0. Is that the one we're supposed to put the 4 in or the other one? It says f of g of 4. Is that f of g right there? Yeah. So we can put the 4 in here. We get a lovely 3/16 minus 4. Is it 61/16? Anyone type in for me? Negative 61/16. Get a fraction. 3/16 minus 4, math, enter. Is that right? Negative 61/16. All right. Should we try it the other way? I don't know. It's kind of scaring me. If we had originally put the 4 in here, we would have had what? 1 over 4. And if we had typed, you could have used 1/4, right? Somebody type that and then do a math, enter, and see if you get the same answer. Does this also give us negative 61 over 16? All right. So the 2 people who are still with me said yes. All right. Now we're on to g of f. What do we have to put in? No. F into g. So we have to put this function all down here. So we get 1 over 3x squared minus 4. Now, this is where the domain restriction gets a little funky. Because what was the original restriction on g? X could not be, it still can't be 0. Even though right now when I look at this, it looks like a 0 would be fine. It would give me negative 4. You have to keep the original restriction. Now, 3x squared minus 4 cannot also equal 0. What do we do? It's not going to factor nice. Could we just square root? What if we add 4 to the other side? Then what? Divide by 3. And then square root. Well, the top square root's to be 2. The bottom square root's to be square root of 3. If I made you rationalize, it would be plus or minus. How do you rationalize that? Multiply top and bottom by square root of 3. So you get 2 square roots of 3 over 3. Do you remember doing that? You're in trig right now. Bet you're doing that all over the place. All right, and it cannot equal 0. So x cannot equal 0, or 2 squared roots of 3 over 3, or negative 2 squared roots of 3 over 3. I don't think it's like that on the quiz, but there might be one like that on the homework, okay? All right, let's see if we can do this. G into F. So G into F would be all of this goes in here. So it would just say 4 square roots of x plus 3 minus 2. Can I simplify that? Nope. The good news is we're done. Except what's the restriction? X plus 3 has to be greater than or equal to 0, which means x has to be, so it would be -3 to infinity if we were doing interval notation. Good job. And that's the one that says f of g of 4. We could have put the 4 into this one originally. We would have had square root of 7. And then if we put that in here, 4 square roots of 7 minus 2. There's nothing nice about that. That's as exact as it's going to get. Did anybody type that? Amanda, did you type that? Anybody 4 square roots of 7 minus 2 get a decimal approximation for me? Okay. And I would be fine with you just leaving it exact. All right, what did we not do yet? We didn't do GOF. How do we do GOF? Put F into G this time. So all this goes in here. I shouldn't have written on top of that. So we will have square root of 4x minus 2 plus 3, which is plus 1. There you go. Okay. All right. Now, if we said 4x plus 1 is greater than or equal to 0, we'd have 4x is greater than or equal to -1, x is greater than or equal to -1/4. Which is more restrictive, the original function or this one? This one says I can include everything from -1/4 on up, but the original function only included everything from -3 and up. Which one is more restrictive? Threw some things away. Yes, so we have to keep this one, -1/4 and up. Because originally we had things like -2 and that won't work here. All right, we get to skip this one. I don't know why it was not a difficult one. Oh, we get to do a disgusting one? Actually, I think we need to skip down to this. Because you don't have this, do you? Okay, but you have homework questions like this. Okay, stick with me because this is tricky. The f function is the red one, okay? The g function is the green one. So when it asks you to find this, some of you still aren't getting how to do the regular reading of function graph. I want g of 2, means when x equals 2 right here on the green function, it looks like we're at, I'm going to go with -4, okay? Now what am I supposed to do? Put that into the f function. So -4 into the red function looks like -9 maybe? Okay, let's try this one. H of 5. Here's H. At 5, it's at about -6. So now I'm going to put a -6 into G, which is this green one. -6 over here looks like about 4. Is this the same thing, but it's different notation, right? Let's do one more. Put into a -3 into G. Which one is G? The green one? So a -3 looks like 1 maybe? And then we're supposed to put a 1 into H. 1 X value of 1 into H looks like about 6 maybe. Okay, can you do that on one on the homework? All right, I hope I'm done. Oh, there's an application, but I don't have time right now. I want to pass back your quizzes. All right, so this is the homework assignment. All right, let me stop the recording and pass back your quizzes.